some of the reactions. Okay, substitution and addition reaction. So you must know that these are the organic reactions. Okay, we call them organic reactions. Okay, so why we use substitution and where we use substitution and when we use addition and where we use addition, so we need to know. So let's discuss first the substitution reaction. Substitution reaction, basically it is a type of substitution, it is a type of replacement when there is four bonds of a carbon atom, and out of those four bonds, one of the its atom is replaced by any other atom. Like we have the carbon, it has the four bonds, as in case of the methane. Okay, so when we use here, now it cannot make further bond, it cannot add both of these chlorines, so this chlorine will replace this one. Okay, and this hydrogen will be replaced and it will react with this one. So in this way it takes place actually in the presence of UV light. Okay, or in the presence of sunlight. So we have this hydrogen and this hydrogen and then chlorine, and we get ICl. This is just a common example just to tell you that this is type of substitution. Okay, so now we are going to discuss when there is substitution. Okay, when there is substitution, when there is no double bond, no double bond. Okay, when there is no double bond of carbon atom. Okay, so suppose we can have carbon atom, so it can have only single bonds. Now based on the you can say that types of the single bonds, this single bond can be polar single bond and non-polar single bond. Non-polar single bonds, and it can be polar single bonds. Let me tell you in case of saturated hydrocarbons. Okay, you would have studied saturated hydrocarbons. So in case of saturated hydrocarbons, let me tell you example of methane. Okay, it has four hydrogens. In the case of ethane, okay, it will also have the hydrogen. Okay, C2H6. So you can see that here the four bonds of each carbon atoms are satisfied by the single covalent bond, and there is no more chance of addition. It cannot make the fifth bond, so that's why it will have only single bond. So you will see that this bond, okay, carbon to hydrogen bond, this bond is non-polar. The same way all these bonds are non-polar. All these bonds are non-polar. Okay, so you can have a look that all these are non-polar because the electronegativity difference between the carbon and hydrogen is very less, so that is ignored, and that's why they have which bond? They have non-polar bond. Now here they will show which type of substitution reaction. Make it clear. It shows free radical substitution reaction. Free radical substitution reaction. Okay, just tell me, let me tell you, you have CH4 plus Cl2 give rise to CH3. One hydrogen has been replaced by chlorine and plus ICl. Okay, and it takes place in the presence of uh, sunlight. Okay, like this. This is the main reaction, and you have studied it has three steps. Okay, it is followed by the homolytic fission, and when you go towards its mechanism, okay, so you know that it has three steps. You already studied. One is called free radical formation. Okay, second is what we call propagation, third is the termination. Free radical formation, second is propagation. Sorry, first step is initiation. Initiation, in which free radicals are formed. Okay, first step is initiation, propagation, third is termination. Okay, so let me tell you what is the initiation. Suppose we have chlorine to chlorine free bond, so it will be a homolytic collision. Okay, so two free radicals will be formed, and this is called initiation. It's the first step. What is second step? That is the propagation, the free radical formation of other substance. Okay, so next substance is CH4. Now chlorine free radical out of these two chlorine free radicals will come, and it will release its one hydrogen, and HCl will be formed, and there will be CH3, and this will be a free radical. Okay, third step is the free radical of both different types combined to form the product of other type. Means one chlorine free radical has reacted and one is remaining, and this second, so both of these terminate, come to a point to form the final product, that is CH3Cl. Okay, so this is the initiation, this is the propagation, this is the termination. So these steps are there in the homolytic, in which type? Free radical substitution. So basically the type is free radical substitution. There is one more type of substitution in case of the polar bonds. Okay, when we have polar bond, how can we have polar bond? Suppose we have the haloalkanes. Okay, all other bonds are hydrogens, and we know that a hydrogen, the bond of hydrogen with the carbon is non-polar, but the bond of carbon with the halogen is polar because it is more electronegative. It attracts the shape pair of electron towards itself. It attracts this bonded pair of electron towards itself, and it has a partial positive charge. So now it has polarity. Okay, its substitution is possible, means this can be substituted, but it will not be substituted easily. It will be substituted by the nucleophile. If we have any kind of nucleophile, for example, we have hydroxide, now it has negative charge, it will attack on this because it has minus charge, and this will be replaced. So ultimately what we will get? H carbon. Okay, and here will be OH, and this X will be released. Okay, so this is called nucleophilic substitution reaction. Means this is a nucleophile. It has negative charge. Okay, it has the excess of electrons. It's looking for the nucleus. Okay, which has a deficiency of electrons. Because it's more electronegative, it's attracting both of these electrons towards itself. So to somehow it has the deficiency of electrons. So that's why it has deficiency of electrons. So nucleophile finds the opportunity to attack on it, and in this way you will see that nucleophilic substitution reactions occur. So let me tell you, this is called nucleophilic substitution reaction. Nucleophilic, this is the second type. Okay, this is the first type of substitution reaction. This is second type, nucleophilic substitution reactions. We can also call SN reactions. Okay, it has two types. Let me explain. SN2 and SN1. When we have alkyl halides, okay, so when there is polar bond, and that polar bond in primary haloalkanes, okay, so it takes place basically in two steps. That's why we call it bimolecular nucleophilic substitution reaction. And when we have tertiary haloalkanes, okay, yes, so they show the in one step, okay, the substitution reaction. So this is called unimolecular. Upper one is called bimolecular nucleophilic substitution reaction because it has two molecules, so bimolecular, and it has only one molecule that which the free radical formation is formed, and then in next step nucleophile attacks. But In mechanism we will discuss all of these. So let me tell you about the SN2. Bimolecular nucleophilic substitution reaction. Suppose we have this carbon and we have chlorine over here, and here we have hydrogen, hydrogen, and hydrogen. Okay, this is called chloromethane, and here we have nucleophile. It has partial negative charge, it has partial positive charge. Now this bond is polar. So when this bond is polar, so it will show which type of reaction? First, all bonds are single, so it will show the substitution reaction. When the polar, so it will show the nucleophilic substitution. And third thing, when it is the primary haloalkanes, okay, so then it will definitely show SN2. Okay, so it will attack on this, because it always we take this arrow from negative to positive. Okay, it has deficiency of electrons because it's more electronegative and it's attracting both of these electrons towards itself. So this OH will attack on this. So as this OH attacks on this and tries to connect it, tries to make bond with this, so it cannot make five bonds. Okay, so there will be a transition state. Okay, hydrogen, hydrogen, hydrogen. In that transition step, the bond formation and bond breaking will be at equal stages. Okay, at equal extent. Okay, so this is not the intermediates, this is for short term. Okay, transition step, and then final products are formed. This gets detached and this get attached. Okay, so you will find that hydrogen, carbon, hydrogen, hydrogen, like this, and this will be OH minus. Okay, there is 100% configuration, inversion of configuration. Okay, and what we get? Chlorine. This is called nucleophile. What we call it? Nucleophile. Okay, this is the primary haloalkanes. This is the intermediate step, and this is the product, and this we call it leaving group. Okay, this was all about the SN2. But what we study in SN1 reaction? This is a unimolecular substitution reaction. In SN1, there is tertiary haloalkane. Okay, for example, the carbon which is attached to the halogen. Okay, let me name here halogen, a specific name. We can call it chlorine, bromine, iodine, any. Okay, so it is further attached to 3 other carbons. Okay, so this is the polar bond. Definitely all bonds are single, so substitution reaction. So this is a polar bond, so nucleophilic substitution reaction. Second thing, and third thing, this is a tertiary haloalkane, so that's why it will show the SN1. Okay, in the first step what will happen? There will be carbocation formation. Okay, it will take both of these electrons because it is more electronegative, so it will take both of these electrons towards itself. Okay, so it belongs to this carbon, and this electron, when it is taken from carbon by chlorine, so there is positive charge. Okay, carbocation means carbon having cation, means positive charge. Okay, when the carbon becomes cation, so it is called carbocation. Okay, and the next is, here is the release of, okay, a leaving group. And next step, this CH3 carbon, CH3, this carbon cation is attacked by hydroxide. And you must know that this is the nucleophile. Okay, attack of nucleophile on the carbocation. So this is the second step. This is step 1. and unimolecular, because in the first step only one molecule is taking part. This is slow step in which the rate of reaction can be determined. Okay, this is the first step. So actually it consists of two steps, and in the first step there is only one molecule, so we call it unimolecular. Okay, so SN1, unimolecular nucleophilic substitution, one molecule is here. But in case of SN2, both of the molecules come together. Okay, so that is called bimolecular. But in second step, this is called step 2. Nucleophile attacks on the carbon, CH3, 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 OH. There is the 50% version of configuration, means 50% will be the same molecules and 50% will be different types of molecules actually. So I'm going to tell you, this is not balanced equation, just to tell you the types of products. Okay, the next product will be like this. Sorry, carbon tertiary alcohol will be formed. Okay, so 50% will be this type of product with the same configuration, and 50 will be the with opposite configuration. Okay, so this was all about the substitution reaction. Now I am going to tell you about the addition reaction. In the same way as we studied about the substitution reaction, addition reaction also has two types, but let me tell you when any atom can show when there is double bond. When there is double bond, carbon to carbon double bond or carbon to oxygen double bond, etc. means presence of pi bond. And you know that pi bond is weaker. Now let me tell you its two types. One is called electrophilic addition reaction. Let me make it clear that when there is carbon to carbon or carbon to any other, when there is double bond, so it doesn't like to have the double bonds, because you know that one is stronger, one is weaker. So carbon likes to have single bonds. That's why its pi bond gets broken and anything is added, one to this side, one to this side. Okay, so both of the atoms which have the double bond, they get broken that pi bond and get attached to one other carbon group of atoms. Okay, and in this way they like to have the single bond instead of having the double bonds. Okay, so electrophilic addition reaction, when they show the electrophilic addition reaction, this is the first type of the addition reaction. Okay, when there is non-polar double bond, when there is let me tell you, in case of alkene, CH2 double bond CH2, this is non-polar. Okay, carbon, both carbon have the same type of electronegativities. So this is single bond, this is the double bond. Okay, the double bond which is called a pi bond, it will attack because this its electrons are exposed. Carbon single bond is found, you know that, by the head-on overlap, and the other bond is found by the unhybridized orbitals which overlap parallel to each other. Okay, and when they have overlapped, so you will see that the electrons density of electrons is above and below. Okay, this pi bond having the electrons above and below the axis of nuclei. Okay, while the sigma have the on the axis of nuclei. Okay, so that's why sigma is stronger, and pi bond, the density of a pi bond is above and below the axis of nuclei. So in this way these electrons are exposed. These are exposed. Okay, these are exposed. So that's why they react. Okay, so suppose I have brought over here, we have ICl. Okay, partial negative charge, partial positive charge. So this will, sorry, it has to be curly. Okay, a bit attack on this, because electrons, they have negative charge, so it will come towards the positive, and this being more electronegative will take both of these electrons. What we will get, CH2 and this hydrogen, okay, and this will be CH2 because both of these electrons, okay, they reacted with this hydrogen. Now it has deficiency of electrons, so that's it will have the positive charge. Now next step, this chlorine which was released as the leaving group and it has negative charge, okay, so now it will attack on this, and in this way it will also get bonded with it, and you will find that it will be CH3, simply we call it CH3 and CH2Cl, okay, chloroethane or ethyl chloride, okay, its name will be. But this is the type of sorry, it's electrophilic addition reaction when the pi electrons from the non-polar double bonds attack on the positive charge, partially positive charged atom. So this is called uh, electrophilic because it has started from the electrophile. Okay, it's an electron loving. Okay, electrophilic substitution reaction. Is it clear? Okay. So now let's move towards the other type that is called. It has one more aspect we need to know. I'm going to tell you. If we have non-polar bonds, still we have non-polar, but the alkene is not symmetrical. Symmetrical means one carbon is here, one is here. This is symmetrical alkene. But if we have asymmetrical alkene, means CH3, CS, double bond, CS2. Now this is propene. Okay, so it is asymmetrical, means the carbon bond is not in the middle. Carbon-carbon double bond is not in the middle. So how the addition reaction will take place? Still it will be through the electrophilic addition reaction, but there are two types of products which we will discuss. Okay, so first let me tell you, we have same ICl, partial negative charge, partial plus charge. Okay, it will attack on this. So now there are two types of, one is CH3, CH and chlorine, and then CH2, it will have plus charge, or CH3, CH, this will be CH, okay, it will not become CH2, okay, CH, CH2 and chlorine, it will have plus charge. Here carbocation is found for some time, okay, this then second there gets attached, okay, but here we have to understand that which one is the major product and which one is the minor product. In fact, in this case, when the carbocation is in the middle and it has two, because they have donating effect, electron donating effect. Okay, they have good inductive effect, you can say. Okay, so it is being induced by the electrons because they give electrons to it from these CS2 and C. So it is more stable. Okay, it's the major product. Okay, sorry, we had to attach hydrogen. Yes, hydrogen will be here and hydrogen will be here because these electrons are going towards the hydrogen. Okay, so this will be the major product and this will be the minor product. We can say this is the 20% and this is the 80% simply. Okay, so next what will happen? The remaining chlorine. Okay, why it is not more stable? Sorry, it's not more stable because it has only inductive effect from one this alkyl group, and it has inductive effect from both of these alkyl groups, so it is more stable as compared to this one. So that's why this is the major product. Okay, but both of these products are formed. Okay, now chlorine that remaining, okay, will get attached to the other. Okay, So two types of products will be formed. One will be CH3 CH, I'm writing here CH2, okay, and CH2 and Cl, okay, or the next will be CH3 CH and chlorine and CH3. So this will be the major and this will be the minor. Okay. So this is in case of, this is the in case of asymmetrical alkene. When we have asymmetrical alkene, so in that case there also definitely takes place electrophilic addition reaction, but that is not a simple one electrophilic addition reaction. That is some type of different electrophilic addition reaction. Okay, and in that there are two major products. You must know that the chlorine goes to that carbon which has less number of, yeah, negative part goes to that carbon which has the less number of hydrogen. So you can see over here, okay, you can see from these two double bonded carbon atoms, okay, which one has the less number of hydrogen. It has more hydrogen, so more hydrogen it will go towards, okay, on this side mainly, okay, and this will go towards this side. So that's why you can see that this is the major product. This is the major product. Other is also possible, but this is the minor product, okay, but this is the major product. Is it clear? So let me summarize that in substitution reaction, just I'm going to summarize it once. In substitution reaction, okay, there are two types. One is called free radical and second is called nucleophilic. Substitution, when there is all carbon to other atoms, when there are single bonds, okay, carbon to carbon or other elements when there are single bonds, when there are all single bonds, there is no pi bond, okay, this is called nucleophilic. Okay, so single, and when the single bonds are non-polar, so it shows free radical substitution reaction, and when the single bonds are polar, okay, then it shows the nucleophilic substitution reaction. You know, it has mechanism and it has two types, SN1 and SN2. I have explained, okay. The next is addition reaction. So you must know that addition reaction is due to presence of pi bond. You know that pi bond is not directly found. First is single and then second is pi. It can be like this, it can be like, so it can be carbon to carbon, okay. So in addition reaction, one example is left, I will tell you, okay. When there is a non-polar, then there will be electrophilic addition reaction, which I have right now explained, okay. And when there is polar carbon to carbon double bonds, mean this is the carbon to carbon double bond, carbon to oxygen, okay, polar bonds. So then what is there? Nucleophilic addition reaction. This I had to explain, let me tell you. Nucleophilic addition reaction. When we have polar bonds, like in carbonyl, okay, here can be R, here can be R, it can be ketone, it can be like this, it can be aldehyde, it can be amide. We have no concern with other groups, okay, we have just concern with this double bond, okay. So this is the one double bond, okay, in which one is a sigma and one is a pi. So pi bond has to be broken. okay, and its breaking results in the addition, okay. So but this is a non-polar, this is the polar, sorry, because it is more like negative, it has partial negative charge, it has partial plus charge, okay. So when it is polar, so nucleophile attacks, let me tell you its mechanism a little bit. Suppose we have carbon double bond oxygen, okay, these are two bonds, we don't care for these two bonds, we have just concern with this double bond, partial negative charge and partial plus charge. Now we have ICN, okay, partial negative charge, partial plus charge. This CN will attack on this, and next try to understand when its bond is formed. Sorry, let me tell you from the start. Actually, this is the partial negative, this has partial positive charge. So this bond will be attracted by the CN. Is it clear? It will have properly negative charge, and this CN will attack on the carbon. Okay, now carbon is going to make fifth bond, so it cannot have fifth bond. So this pi bond being more like to negative, this oxygen will attract this pi bond towards itself. So what will happen? Carbon, when it gets attached to the CN cyanide group, okay, these are two bonds as it is on the left and right side. This double bond, one of the double bond is shifted towards the oxygen and it gains the negative charge, okay. And now this hydrogen is left and it has entirely plus charge. Now in the second step, this will be attached and you will find the carbon having OH, having CN, okay, like this. So it's clear now, it's crystal clear that addition of ICN has taken place. Actually it has mechanisms, okay, but overall you have understood that pi bond has broken down, some portion has added on this, okay, one of the its portion is added on this, okay, and this pi bond has been broken down and double bond has converted into a single bond, and this is the main product. Okay. It can have mechanism, definitely it can have like we have aldehyde, okay, we take it specifically aldehyde CH3, okay, ethanol we have. I'm going to add here ICN, but to add ICN in the mechanism we know that we have NaCN, it gets broken into Na plus Cn negative. So now this Cn negative attacks on this carbon, okay, and it makes fifth bond and this bond is shifted towards the oxygen. What will happen? CH3 carbon hydrogen CN oxygen negative, okay. Now next is addition of, we bring the ICN, that main product we had to add, ICN, okay, ICN. This CN actually is coming from the catalyst, it's acting as a catalyst, it initiates the reaction, okay. So this is partial plus charge, partial negative charge, so this negative will attack on this, okay, and the being more electronegative, this bond will be shifted on the CN. So what we will find? CH3 carbon hydrogen, this will be CN, okay, this will be OH, okay, because this H will be attached on this, and what will get? CN will be released. So this CN which has been released, okay, because it was added over here and it is being released as it is, so it is acting as the catalyst. So simply we can say that it started the reaction and speeded up the reaction, increased its speed, and now at the end it's going to be released as it is being unchanged. So anything which remains at the end of the reaction unchanged and would have increased reaction is called the catalyst, okay. And in other words, you can see that CN has been added over here and H has been added, so this addition of HCN, okay, hydrogen cyanide. So in this way you can see the other examples of the addition, which are the nucleophilic addition reaction. Okay, addition on the pi bond and substitution on the single bond. Okay, the non-polar single bond is there, then there will be free radical substitution. If polar is there, then nucleophilic substitution. If non-polar double bond is there, then there will be electrophilic addition, which will have two products, minor and major products. And if there is the polar like this, okay, sorry, I forgot to write their charges. Okay, if there are polar bonds like this, so then there will be addition, which will be called nucleophilic addition. Will be initiated by the nucleophile. Okay.